Lesson 3, Reasoning about Equations with Tape Diagrams. On 3.1, Finding Equivalent Expressions, you're going to select all the expressions that are equivalent to 7 times 2 minus 3 times n, and explain how you know each expression that you select is equivalent. So you should know the distributive property, which tells you distribute the 7 to both terms inside. So that means 7 times 2 minus 7 times 3n. So 7 times 2 is 14. And 7 times 3 times n would be 21n. So we know 3 would be equivalent because of the distributive property. But are there any others that would be equivalent? 4 would also be equivalent. So the only thing that's different is the 7 is behind the parentheses instead of in front of it, which using the commutative property, that tells me that it's still equivalent. So another option, when you're not sure, is that since we have a variable, we could choose any number to represent that variable. So we could use 0 as n, and then find the value of each expression. When you use 0 as n, you would get the same answer on number 2 as you would for your original expression. But we know 2 is not equivalent, so you want to be careful when you just plug in a number. Sometimes it helps to plug in 2 numbers just to make sure. So if I also used n equals 1, then this would no longer be equivalent because I would get a different answer. So that tells me that it's not equivalent. Because if it's equivalent, it would equal the same value regardless of what number you selected for n. Okay, on 3.2, so you're matching each equation to a tape diagram. So on our first equation, we have 2x plus 5 equals 19. So write that down here. 2x plus 5 equals 19. So which tape diagram would match to that? Okay, we could use A or B for that one. So x plus 5. Well, we know multiplication is just repeated addition, so x plus x is the same thing as 2 times x. And diagram A is the same thing, except the 5's listed first. And since it's all addition, the order does not matter there. Okay, your next equation is 2 plus 5 times x equals 19. So which diagram would that match? Diagram C. So we have 2 plus x plus x plus x plus x plus x. So we have 5 total x's and repeated addition. I know that 5 times x is the same thing as x plus x plus x plus x plus x. And then we have a 2 to add to that. Okay, next one is 2 times x plus 5 equals 19. So which diagram would match that expression? Diagram D. So we see that D is broken up into 2 equal parts, and they're both labeled x plus 5. So that's x plus 5 plus x plus 5. And since we're repeatedly adding the same thing twice, then that would be the same thing as 2 times x plus 5, which is 2 groups of x plus 5. Okay, next is 5 times x plus 2 equals 19. Again, we have 5 groups of x plus 2, so that would be diagram E. Okay, next equation, 19 equals 5 plus 2 times x. Okay, so that would be A or B again. Because if you notice, this equation is the same thing as this one, except they use the commutative property. So the 5 and the 2x switched places. And it's still equivalent because if we have 1 plus 3, that would be the same thing as 3 plus 1. So the order can switch there. Next equation is x plus 5 times 2 equals 19. Okay, that would also be D. That's just like the first problem that we worked on 3.1. So the commutative property of multiplication means the order can switch and the answer would stay the same. Okay, next equation is x plus 2 times 5 equals 19. And again, just using that commutative property, so diagram E. Then we have 19 divided by 2 is equal to x plus 5. Which diagram would match this equation? That would be diagram D. So we see that diagram D is split up into 2 equal parts. And so when I divide that by 2, I'm given 2 equal parts of x plus 5. And last equation, 19 minus 2 is equal to 5 times x. That would be diagram C. So if you look at these equations, 2 plus 5 times x equals 19 in this diagram. So 2 plus x plus x plus x plus x plus x, which is the same thing as 2 plus 5x. Well, to figure out what 5x would equal, I would need to subtract 2 from 19, which is what they have done here. (3.3) Drawing tape diagrams to represent equations. So it wants us to draw a tape diagram to match each equation. So first, let's do our first equation. So we know we got to start with a rectangle. And I know that it has to represent a total of 114. So now I have to determine what would go inside of my diagram. I know I have 3x plus 18 is equal to 114. And if I wanted to expand that out, I know that x plus x plus x plus 18 equals 114. So I see here that I have 3 of the same thing, which means 3 of my boxes need to be an equal size. And then I need a 4th box that has 18 inside of it. When I think about my total being 114, I know that my box of 18 would need to be smaller than my other boxes because 18 is not a very large number. And then I need to draw 3 equal boxes, which mine are not equal. But I know that inside each of those boxes, I would have x. So now I have x plus x plus x plus 18 equals 114, which is equivalent to 3 times x plus 18 equals 114. Okay, a diagram for 114 equals 3 times y plus 18. So again, my diagram needs to be equal to a total of 114. And I know that 3 times y plus 18 would give me 114. So 3 times y plus 18, so that's the same thing as y plus 18 plus y plus 18 plus y plus 18. So I have 3 groups of this. So 1, 2, 3. And since they're all the exact same, then I know I just need to split this up into 3 equal parts. And each part would be labeled y plus 18. So we have 2 different diagrams that both add up to equal the same thing. And on number 2, we're going to find the values for x and y that would make these equations true. And you can use any method. So let's look at the first equation. We have 114 equals 3x plus 18. Well, if I look at my diagram, I know that these 3 are the same thing, and then I have 18. So to know what my 3 equal parts are, I need to figure out what the 3 equal parts have to equal. And my 3 equal parts plus 18 is 114. So first I would want to subtract 18. So 114 minus 18. So that equals 96. So I know that my 3 equal parts have to equal 96. So then I could just divide 96 divided by 3. And that tells me that each part is equal to 32. So my x variable represents 32. Okay, on the second diagram, so I have 3 equal groups of y plus 18, and that has to equal 114. So I could figure out what each box represents. So each group would equal what if they're equally distributed. So 114 divided by 3, which is 38. So I know that each of these boxes represent 38 plus 38 plus 38. So if each one equals 38, then I know that y plus 18 has to be 38. So then I could just subtract 18. So 38 minus 18 is 20. So I know y equals 20. So both equations equal the same thing. However, because my equations are different, my variables represent a different number.